we're going to look at distributive property. Okay, distributive property is the idea of like expanding and simplifying. They probably tell you it's the exact same idea. You're probably going to have to use distributive property. And distributive property is a way to go from your vertex form of a quadratic to your standard form of a quadratic. So you would use distributive property or expand and simplify to go from vertex to standard, or even actually, if you recall, factored form kind of looks like this. I should have wrote that in. You would use it also to go to standard form. Okay, so it's a pretty popular one to do. We chose vertex form because it's a little harder to work with. So if you can do vertex form, you can definitely do factored form. So I have my vertex form, and we're going to use distributive property to put it in standard form. So the first thing I need to do is I need to expand these brackets. Now this bracket here, though it's not just one number, remember if I had written like 5 to the power of 2, that's rewritten as 5 times 5. The problem is the base here, in this example, is just a number 5. Here the base is x plus 3. So I have to do x plus 3 times x plus 3 when I distribute. So now we have x plus 3, x plus 3. I've now essentially eliminated that square. I've written it out in its long form. That's what we did here. Okay, so we've written it out in the long form, and now we need to use distributive property, or also known as FOIL. Do you remember FOIL at all? Yeah, FOIL is your first terms, your outside terms, your inside terms, and then your last terms. Okay, so we'll deal with that. We have our -2. So our first terms are x times x. So x times x is x squared. Our outside terms would be the very first and the very last term. So x times 3. X times 3 is 3x. So we've now done our outside terms. Our inside terms would be the 3 and the x in the other one, so the two closest to the middle. 3 times x is still 3x. And then the very last terms in each bracket, that would be 3 times 3, which is 9. Okay, so I've done a different color for each one, but if you take a look at how it's been underlined, you'll notice I've used this one twice, this one twice, this one twice, and that one twice. So they've all been used twice. That way we kind of know, okay, we must have done it properly. And then finally, that -4 still comes down. So we simplify what's in the brackets. There's only two things that can be simplified in this bracket, and that's 3x plus 3x. They're the only set of like terms. Okay, so I just add the coefficients. 3 and 3 is 6, so I'm left with 6x and plus 9. The reason these are not like terms is this is to the power of 2. This is technically the power of 1. You could say this is to the power of 0, but there's no variable here. So I can't really do anything else. These three have to stay the way they are. Okay. So that's the first type of distributive property, is your FOIL. The other type that you probably would have done in grade 9 is now we have to distribute the one term to all three of these terms inside the bracket. Okay. So remember I told you vertex form is the long one. It takes the longest. So now we do -2 times x squared. That's -2x squared. -2 times positive 6x. So we just multiply the coefficients, okay? -2 times 6 is -12, and the x just stays, okay? And then, I guess I should show those in red, that the coefficients are changing, okay? And then -2 times positive 9 is -18. So those are the things that have changed. And now the brackets can drop off because we distributed everything, so I can just bring down that -4. It doesn't have to be outside any set of brackets. So now I start trying to collect my like terms. I'm in pretty much the same scenario. This is to the power of 2. This is to the power of 1. These guys don't have variables. So these guys don't have any like terms, but they do. These two are like terms. So I can combine the last two values here. So let's combine these last two values. Okay, so -2x squared minus 12x. And -18 minus 4 is -22. And lo and behold, this is your standard form. I can't go any farther here. This is my A term, this is that B term, and this is that C term they showed above. Okay, so that's the hard version of distributive property. This would be kind of the most work you'd have to do with it.